to explain why the pass probability doesn't linearly correlate with the angle theta, and why it should correlate with square of cosine theta. There are two possible scenarios when light pass two polarizer A and B. First, two polarizer A and B are at 0 angles. Then turn B from angle 4 to 5. Scenario 1. The photon passes polarizer A and B without change its polarization. Angle 1, 2 is how much the photon passes before the polarizer B turn from angle 4 to 5. Angle 2, 3 is how much the photon passes after the polarizer be turned. As you can see, angle 2, 3 and angle 4, 5 are negative linearly correlated, which means probability of photon passes both A and B are linearly correlated with the angle. Scenario 2. The photon passes polarizer A and B with changing its polarization. Polarizer A and B are set on angle theta. When photons pass the polarizer with angle theta, the energy of photons wave can be split to two components along xy axials. The probability of two directions that the photon have to change is correlation with these two components, sine theta and cosine theta. Because the sum of two probability must be 1. Sine theta square plus cosine theta square equals 1. So angle theta and probability of photon passes both A and B are square of cosine theta correlated. The light will change its polarization when pass polarizer has been known for a long time. So the scenario 2 is what's really happening. It doesn't have to use any quantum mechanics theory to prove angle theta and probability of photon passes both A and B is square of cosine theta correlated. Wait a minute. Quantum mechanics says the photon is in superposition when it hit the polarizer. Two entangled photons are polarized in all directions before it choosing to pass polarizer and simultaneously tells its entangled partner. There is no experiment proved this yet, and quantum mechanics just says it and everybody believes it. How to prove it's wrong? Well, if the superposition photon is polarized in all directions before it hit the polarizer, it should be able to pass it every time. There is no reason not pass unless sometime its position is too far away from passing direction. So the superposition is not all direction evenly, which means the superposition is wrong.